Hi, in this video we're going to continue solving using the square root method. And let's try a few problems. We're going to start with x squared plus 4 equals 0. Now recall, in our last video what we said is we isolate the perfect square. And so our perfect square, that'll work. Our perfect square is this, it's the x squared. So we want to get that on one side, and we want everything else on the other. So we subtract the 4 from the left, subtract the 4 from the right. And now I have x squared equals negative 4. Now we take the square root of both sides. So I have a plus or minus the square root of negative 4. Now here's what's exciting. It used to be that you wouldn't have been able to solve something like the square root of negative 4, but now we know that this gives us x equals plus or minus, and remember the square root of negative 4 is 2i. And that's how we can solve that one. Now let's try one where there's a new subtlety introduced. So here we go. Let's solve 2x minus 1 squared equals 1. Now, here's what makes this problem a little bit more advanced, and that is the perfect square. The perfect square is this entire piece. 2x minus 1 is that entire piece is being squared. So, in other words, we've got the perfect square is on one side, everything else is on the other, so we can solve it by taking the square root of the perfect square. So the square root of 2x minus 1 squared, and then we're going to have a plus or minus the square root of 1. Well, this is going to, the square root of something squared is just going to give us the base. 2x minus 1 equals, now I have a plus or minus the square root of 1, that's 1. Now, let's see. Now we're going to add 1 to both sides. Now this gets a little interesting here. So I'm going to add 1 to both sides. And I'm going to kind of line it up kind of tight like this. You'll see why. Because so now I have 2x equals 1 plus or minus 1. Now watch what happens here. So this plus or minus has got to stay. This plus or minus has got to stay. It's not a like term yet, because remember, it represents two possible cases. Now I take and I divide everything by 2, solving just like you would expect at this point. So now I have x equals 1 plus or minus 1 divided by 2. So now, watch what happens. There's two cases written here. One is x equals 1 plus 1 divided by 2, or 1 minus 1 divided by 2. So if we simplify those, this is going to be x equals 1, or 1 minus 1, that's 0. 0 divided by 2, that's 0. So you could write 1 or 0, or you'll often just see it as x equals 1 comma 0. Okay. One last example here, and that is solve 4x minus 3 squared equals negative 2. Okay? It actually looks quite similar to the one we just did. I'm going to scroll down up here, and if you look, the perfect doesn't quite fit, but the perfect square is already isolated, just like it was up above. So we're ready to go. The perfect square is isolated, so I can take the square root of 4x minus 3 squared, and we'll take plus or minus the square root of negative 2. On the left-hand side, I have 4x minus 3 equals, this is going to give me a plus or minus I times the square root of 2. Wow, that's an interesting looking answer. Then, let's see. Now, this is going to be kind of strange. It's because we're going to have a lot of unlike terms. So we'll add 3 to both sides. This is going to be 4x equals 3 plus or minus I times the square root of 2. Then I divide both sides by 4, and I have x equals 3 plus or minus I times the square root of 2 over 4. And that is how you solve that. And you could write your answers also like this. So you could have x equals 3 plus I times the square root of 2 over 4, comma, 3 minus I times the square root of 2 over 4. And that is how you use the square root method even for some bigger problems. Thanks for watching.